This video presents the fundamental concept called a class of object-oriented programming. In doing so, we will see UML class diagrams as a way to describe classes. In a pure object-oriented language like Python, everything, that is, every item of data, is called an object. Every object has a type and a value. For example, the leftmost box shows the whole number 3, that is, an object whose type is int and whose value is 3. The second box shows the number 3 again, but this time represented as a floating point number. The third box shows an object whose type is string and whose value is the sequence of characters HELLO space WORLD. The rightmost box shows an object that is a sequence of things. Its type is list, and its value is the ordered list of items. 1, 1, 2, 3, 5, 8. An object's type determines what kind of thing the object is. That means that the object's type determines what kind of things the object knows and what kinds of things the object can do. For example, an integer or a float knows its number and can do arithmetic with other ints or floats. A string knows its characters and can do things like return an uppercase version of the string. Likewise, a list knows its items. It can reverse its items, tell how many items the list has, which is called the list length, and many other operations as well. The central idea of object-oriented programming is that you can create your own types by writing what is called classes. For example, if you are interested in a sketch program that lets the user draw shapes on the screen, you would probably choose to make a point and a line class, as well as a canvas class for the thing upon which you draw the shapes. If you are doing a program that dealt with animals, you might have a dog class, a cat class, and an animal class as well. If you were simulating a city, you would probably want a vehicle class with various subclasses for types of vehicles, and also classes for parts of vehicles like axles and wheels. The power of object-oriented programming comes from the fact that classes can have relationships. More on that later. For now, let's focus on a single class. A class always has 3 things: a name, instance variables to hold the data that the instances of the classes have, and methods that instances of the classes can do. For example, consider the point class. What 2 items of data would a point have? Pause for a moment to figure that out. Yes, it would need an x and a y for its coordinates, assuming that it is a point in 2 space. Here, the designer of the point class chose the natural names x and y for the 2 instance variables of the point class. Other languages use the words field or data members instead of instance variable, 3 ways to say the same thing. A point might have other instance variables, for example, a variable that indicates whether the point should currently be visible or not on the canvases on which it is drawn. Now, think about what methods a point class might have. That is, what should a point be able to do? Pause for a moment to come up with some things that a point should be able to do if we were making a sketch application that allows the user to draw shapes on a computer screen. Perhaps you decided that a point ought to be able to move by a specified amount in the x and y directions. Maybe it should be able to be reflected about a line, which would cause the point to move in a certain way. Probably one ought to be able to attach the point to a canvas on which the point would be drawn. There are lots of possibilities, and this is certainly not the only design possible, but I hope you see the central ideas. An object knows things, that is, it has data, described by the instance variables of the class to which the object belongs. An object can do things as described by the methods of the class to which the object belongs. Note that there can be many point objects in existence at the same time. We call those objects instances of the point class. All instances of the point class as designed here have instance variables called x and y, but each instance has its own value for its x and its y. For example, we might have one point at 5020 and another at 10100. And when a point moves, it changes its instance variables. So if the point at 5020 is asked to move, say, 10 to the right, it would change to 6020, but that move would have nothing to do with the point at 10100. As another example, consider the line class. What would you expect it to have as its instance variables? Pause for a moment to decide. Surely the line should have 2 points for the 2 endpoints of the line. The designers of this line class chose to call them start and end. Note that instance variables can be instances of classes themselves, as here the start and end instance variables are instances of the point class. The value of an instance variable does not have to be a simple number. It can be any type that the designer of the class chooses. The designer of this line class chose to include instance variables for the fill color and other things useful for drawing the line. What methods do you think a line should have? That is, what do you think a line ought to be able to do? Pause for a moment to decide. The designer of this line class chose to allow a line to do similar things to that which a point can do, plus also things like hiding and showing itself. Again, it is all up to the designer of the class. In the next video, you'll see how you can use whatever instance variables and methods the designer has provided. We'll see the notation then. But a UML class diagram, like the examples shown here, shows the 3 parts of any class. First, the name of the class. Second, the instance variables of the class, which keep track of what the object knows, that is, the data associated with the object. And third, the methods of the class, which specify what an instance of the class can do. Those 3 ideas are the key takeaways from this video.